Alright, welcome everybody. Today I want to cover the CNT 125 online inner VLAN routing lab with you. I'm going to start off by going over the initial discussion of the lab. We're going to subnet it based on the requirements that are on the network and the map. And then I'm going to switch it over, show you how to plug up a regular set of routers physically, but then we're going to do the lab in Packet Tracer on my PC, which will make the quality a little bit better, but I always want to start off with this piece for you. So let's go ahead and get started. Based on this lab, the Acme Super Glue Company needs their network subnetted to help organize the network. Now, they've decided to use private addressing behind the firewall, which is what we all do because we don't have enough public IP addresses out there. They're going to use a 172.16.0.0 network, which, as we know, has a default subnet mask of 255.255.0.0 or a /16. Now, you'll need to assist them with the additional subnetting they need to complete their network configuration. Now, we're going to scroll down to the bottom. You're going to see we have a map, okay, of their network, and we're going to see how many networks they need, and then we're going to discuss on how we're going to set it up. Alright, so now here we have our routing map. Now, I always try to tell my students, always route with a map, always route with a plan. Never program your routers without that map, okay? So let's go ahead and take a look at what we've got on this map that was what we're asking of the network admin. What are we asking you to create here? Well, you can see we just have a 2811 router. We can use a 4321 if you want also. And we have a standard layer 2 managed switch. So that means we can create VLANs on it. We have PC1 on VLAN 10. We have PC2 on VLAN 20. And we have PC3 on VLAN 30. So right out of the gate, I know I need 1, 2, 3 networks to get this thing working. Plus, I usually want to have a 4th network for my management network of my router itself. So I know I need to have at least 4 networks. Okay, so I have my admin VLAN, my staff VLAN, my voice VLAN, and my wireless VLAN that I need to be able to create networks for. So that's going to be a minimum of 4 networks. We know that 2 to the second equals 4. So we're going to borrow 2 bits on our 172.16.0.0 network. So let's get started on breaking that down, shall we? Alright, so if we start over here, and as always, we go with our 2, our 4, our 8, our 16, 32, 64, 128. We can keep on going on and on and on for that, but we've already hit the number that we need, and that number is going to be the 4. So, with that being said, I'm going to borrow 2 bits from my 172. So I have my 172.16.0.0. I borrowed 2 bits, which means I'm going to have a subnet mask of 255.255.192.0. I didn't borrow 6 bits out of my octet, my 3rd octet, which means that now my my networks are going to be in multiples. My networks are going to be in multiples of 64. 2 to the 6 is 64, right? 1, 2, 3, 4, 5, 6. So my first network is going to be, if I do my network column and my broadcast column, okay, I'm going to have 172.16.0.0, 172.16.64.0, 172.16.96. 128.0. And 172.16.192.0. I know I'm at the end because my last network equals that of my subnet mask. And the broadcast on this one here is going to be 172.16.63.255, 172.16.127.255, 172.16.191.255, and then 172.16.255.255. And my host ranges will be the numbers in between my network and my broadcast addresses. Next, I want to start assigning the network configurations for each one of my interfaces that we're going to create. Now, unfortunately, I'm not quite tall enough to reach that guy right there, so I'll be right back. Get a little step stool. All right, so now I'm going to have 172.16.0. Okay, and this is going to be for fast Ethernet 0.1. So this isn't my network. This is the actual interface. We're going to make that a 1, and it's going to have a 192.subnet mask. So this is my .0.0 subnet right here. Okay? So to speak. It's really everybody. The next network that I'm going to create is my 10 network, which is my 64 network. So this is going to be 64.1 with a 192 subnet mask. VLAN 2 is going to be my 128.1 with a 192 subnet mask. And my last VLAN is going to be my 192.1 with a 192 subnet mask. Okay? Those interfaces right here, although I only have one port that I'm plugging into, I have to switch things up a little bit. I have a limitation here. This is what is really cool about this lab. It's called routing on a stick. We're going to create sub interfaces on this guy right here, okay? And the interfaces are going to be FA0/0.1, FA0/0.10, or gigabit if we're using the 4320, 43 series routers. FA0/0.20. That means I'm using the 00 interface, the physical interface here, and then I'm going to create sub interfaces on that interface to make these, and this is going to be my .30 interface. Okay. Then down here on the bottom, I'm going to assign each one of these PCs, okay, to the networks. Okay. So this guy here will be he'll be on the VLAN 10 network. So the VLAN 10 network is right here. That's my 64. And usually we like to jump in and start our IP addressing at the 10 or 11. And then the 192 subnet mask. Okay. And the slider notation on this, okay, we have a /16, we borrowed 2 bits, so we're going to have a /18. The default gateway on this guy here is going to be the IP address, okay, of the 64.1. So when he needs to leave the network, he'll go to this interface here. His IP address will be on the same network as the sub interface of this guy, which will allow him to traverse the router and leave the network. This guy here is going to be the 128. We'll make him a 10, 192, and he's also going to be the /18, and his default gateway is going to be the 128.1. This guy here is going to be part of the 192 network. /18, and he's going to be the 192.1. So now our map has been taken care of. So our next step is going to be setting up our routers. And we'll do that next. Okay, so normally I'd be doing this lab for you guys in a packet tracer, but I wanted to give you guys the opportunity to at least see what everything is going to look like on a physical router. Now right now I just turned these on, so that's why they're all lighting up here like crazy and everything. It's just going through a boot sequence. I'm using a Cisco 1941 router, which I'll replicate for you again over on the packet tracer. But over here I have my Ethernet port. So right here I have my G0/0 port on my router. Here I have my G0/1 port on my router. Now I have a 48 port switch here that I'm using for my physical racks. We will be using a 24 ports on our packet tracer lab. So what I might do if I was using this one here, and what we'll do is I'm going to use ports 1 through 5, so it's 1, 2, 3, 4, 5, ports 1 through 5 here for Vlan 10. Then I'll use ports 6 through 10 for my Vlan 20, which is my voice Vlan, and then I'll use 12 through 18 perhaps for my wireless Vlan. So if I was going to plug all of this up, I would then very simple. I would come over here to my last port. So on this one here is my 48 port. On the routing labs that we're going to be doing, I'll be using port 24. So on this one here, I'm going to plug in to port 48, and then I'm going to plug that up here. Now the reason this is my trunk port. Now trunk ports are used so that we can take multiple VLANs off the switch and bring them up through one cable here to the interface of our router, which will then have sub interfaces on it. Then PC1, which will be plugged into VLAN 1, say would plug into port over here in VLAN 1. I would take a PC2, which is plugged into VLAN 10. I'm sorry, this would be VLAN 10 here. Then VLAN 20 would plug in here. And then I would plug in this cord here off of say VLAN 30, which is my wireless VLAN. And these three networks here now, my sub networks, will be able to communicate to the router through the trunk port. When I'm programming my router, I would then take my cable. Maybe just bear with me here, I'll get you a cable. I would take my cable, my console cable here, and I would be able to plug that into my router here, to plug that in, and then I would be able to console into my network. If I were programming my switch, you'll see that my switch does not have a console port in the front. So I would have to come to the back of my device, and I would plug in my console port here. Nice and simple like that. So let's go ahead and program these routers, shall we? Okay, welcome back everybody. After we just got done hooking up our actual physical routers, I'm going to do the actual coding demo with you using Packet Tracer just to simplify things a little bit. So here we are. We've got our network. We got our network plugged up. It's a little bit different than the Packet Tracer that you were doing. Only in essence, I programmed or plugged up the a Cisco 1941 router. Then you can see here that I actually gave ourselves a Cisco 1941 router, similar to almost exactly to like the one that I have in the earlier part of our video, showing you that I plugged in to our trunk port right here, the G00 port, and I plugged a G01 into the internet going out. And I didn't simulate that in our packet tracer simulation here, but I can do that for you if we ever need to. Okay. Then we're plugged down in here to a 2960 switch. The switch that I used on the rack that I have here in my classroom is a 48 port, but nonetheless, we will still be using the last port, the 24 port, port 24 as my trunk. And then I plugged in PC1 into the first 6 ports. I plugged in PC2 into the next 6 ports, and I plugged PC3 into the following 6, starting at 12 to 18 for VLAN 30. So let's go ahead and get started. Now, it really doesn't matter how you decide you want to work your network. I personally like to work from the ground up. So I'm going to start here at layer 2, and I'm going to work on creating my VLANs for my networks. Right? So first thing we want to do is we get into the command line interface. We want to get into the our switch console. We want to name our switch first. So I'm going to go into configure terminal, and I'm going to name my switch something awesome like switchy poo. So there's my first switch, and I want to get in and I want to set up, according to my map, I want to set up VLAN 1. VLAN 1 is my management VLAN of my switch. Now, on the router, we said the interface for VLAN 1 was going to be 172.16.0.1 with a subnet mask of 255.255.192.0. We want our switch to be on the same network as VLAN 1. So we're going to get into the interface of VLAN 1. You'll see my my prompt change to an interface, and I'm going to add an IP address to this interface by saying 172.16.0.2. You cannot have it be the same IP address as the router. It's got to be one different, or just has to be different, but it has to be on the same network. So it has to be on the 172.16.0.0 network. Give it my subnet mask. Every IP address must be paired with a subnet mask. And by default, the interface is down, so we're going to give it a no shutdown command. And now our interface just came alive. Let's go ahead and exit out. Get us back to the configure terminal. Now we're going to go ahead and we're going to set up our individual VLANs. We have a VLAN 1, which is our administrative VLAN. We have a VLAN 10, which is, let me pull up my map here real quick. VLAN 10, which is my staff VLAN. We have VLAN 20, which is my voice VLAN. And I have VLAN 30, which is my wireless VLAN. So let's go ahead and set up our first VLAN. We're going to say VLAN space 1. This is different than the interface of the VLAN. The interface gets an IP address assigned to it, whereas the VLAN doesn't get an IP address, it just gets a name. So let's go ahead and name our VLAN. We're going to name this one admin because it's our admin VLAN. Oh, my bad. VLAN 1 cannot have it's just VLAN 1. It does not get a name because it's a default VLAN. So let's go ahead and leave that alone. It takes it out of that. Let's go to VLAN 10. And VLAN 10 is our staff VLAN. So let's go ahead and name it. Let's exit out of that. Let's go to VLAN 20. Name it voice. Exit out of that. We're getting VLAN 30, which is our wireless VLAN. Name that And now if we do a show VLAN, you'll see that we have VLAN 10, 20, and 30 are our staff voice and wireless VLANs. You'll see that VLAN 1 already exists because it will always exist because that is your default VLAN. And you'll see right now all my interfaces are all assigned. Make it a little wider so you get a better look. Okay, it's our default VLAN. All of our interfaces are still currently assigned to VLAN 1. We want to be able to change that. So our next step is to add interfaces to VLAN 1. So let's go back into our global configuration mode, and we're going to go into the interface range FA0/1 space a dash and a space. Now the reason I'm specifying space here, because depending on the iOS of your switch, you may or may not have to put a space in here. So we're going to take this all the way up to interface 5. You'll notice I also did not make it FA0/1-FA0/5. We hit enter. You'll see my interface or my prompt has changed to the config IF range. So what I want to do now is do a switch port access, and I want these guys to access VLAN 10. So what I've done right now is I have assigned ports 1 through 5 to VLAN 10. I'll exit out of that. I'm going to go into my interface range, and I'm going to make this one 6 to 11. See, my range has changed again, and I'm going to do switch port access VLAN 20 to assign those ports to VLAN 20. This is important that we have these numbers correct, because when we go back later on, this is what we call tagging. We are tagging these ports with a 10 or a 20. So when these ports go up to the router to talk through the trunk, they'll have a 10, a 20, or a 30 assigned to them. That then directs the traffic coming from those ports to the appropriate sub interface on the router. So now I'm going to go to interface range FA0/12 all the way to 17. Now you'll notice I did not exit on that one there. It will allow you to go from interface to interface without exiting back. It can get a little confusing if you haven't done this for a while. Let's go ahead and do a switch port access VLAN 30. So now let's go out of here, take ourselves back to the to privilege exec mode, and let's do a show VLAN on this now. And as you can see that 1 now has 18 all the way up to gigabit port 2, 10 has 1 through 5, 20 has 6 through 11, and 30 has 12 through 17. Those ports are now all tagged and are part of particular VLANs. We still need to program the end port, the one that we plugged in. Okay, this guy right here, he's plugged into port 24, and he needs to go up into gigabit 0/0, so that VLANs 10, 20, and 30 can all trunk up into the router so that they can all eventually communicate with each other. Because right now, PC1 cannot communicate with PC2, and PC2 cannot communicate with PC3, even though they're all programmed and plugged into the same switch. So let's go ahead back into here. Let's get into global configuration mode. Let's get into interface FA0/24. And we just want to change the mode to trunk mode. So now if I go through and do a show run, you can see that what my ports are assigned to. For example, port 2 is assigned to VLAN 10, and port 7 has access to VLAN 20. Port 14 has access to VLAN 30. If it doesn't have a port assigned to it, then it is by default part of the default VLAN of VLAN 1. And then you come down here, you see the interface Fast Ethernet 0/24 is assigned to a trunk. So that it means it is in trunk mode. At this point here, to prevent like any mishaps, you would want to do a copy run to the start. Okay, choose the default name of start config, and then we just rolled through. Let's go ahead and get out of this interface. At this point here, I would unplug the console cable from my switch, and then physically plug it into my router and hit my enter key, and end up here at my command line. Okay. Always, it should say, would you like to enter initial configuration mode? At this point here, we would want to say no. And then we're going to want to hop in here, and first thing we're going to do is we're going to name our router. Okay, so go into enable mode, or what we call privileged exec mode, then in configuration mode, or global config, and we're going to change the name of our router. Our switch was Switchy Poo, so let's just change this to Router Poo. It just sounds cute. Next thing I want to do is I want to go into interface G0/0, and I want to create my sub interfaces so that they can be on the same networks as my VLAN. So we're going to get into interface G0/0. Okay, you'll see our interface has changed. Now what's important here is that G00 cannot have an IP address assigned to it. So we're going to say no IP address to G00. We're going to make sure that interface 0 is always up. So we're going to do a no shutdown command on G00. So now G00 is up, even though it can't communicate with anything literally at this point. I want to get into the interface of G00.1. That is now my admin VLAN. So I'm going to come in here, and I want to give it a description so I know what it is. So I'm going to say description router. Let's get all bolded out here. Router interface for admin VLAN 1. Now I want to add an IP address to this, but in order for me to add an IP address to a sub interface, it has to be encapsulated, and I'll show you that real quick. So I'm just going to do an IP add, and I'm going to do the 172.16.0.1, which puts it on the same network as the switch, okay, now you're going to get an error here. It says configuring IP routing on a LAN sub interface is only allowed, okay, if that sub interface is part of the IEEE 802.10 and the 802.1Q. So that means we have to encapsulate the trunked data that's been tagged to VLAN 10. We have to encapsulate it before we can add an IP address. So now we do encapsulation dot 1Q, then a space, and then we just put in the VLAN number that we want to encapsulate it to. Now you'll see that it took that command. Now we're going to go ahead and add the IP address 172.16.0.1 space 255.255.192.0. And now it just comes up right there. Sweet, right? We're going to do the exact same thing again for our other interfaces. So now we want to get into, and we don't have to, we can get out if you want, that's fine. We're going to say interface G0/0.10. This, as we said earlier, is the interface for our staff VLAN. So let's just start off real fast by saying description. Let's make this one caps as well. This is the router interface for staff VLAN 10. We have to encapsulate the data. .1Q is the protocol that we use for encapsulating our data. Do a space and then do 10 because that is the VLAN we are assigning it to. Then we can do our IP add 172.16.64.1, always paired with a subnet mask. And we don't have to do a no shutdown command here because the entire interface itself is already up. Now I'm going to jump over to the interface G0/0.20. My bad, I didn't do a dot. Okay, the interface is now up, and where it says line protocol for interface .20 is here. We'll do our description, and this is for VLAN 20. I'm going to encapsulate it using the .1Q command to 20. I'm going to add the IP address to the second network, or third network really, which is 128. I'm now going to jump over to interface G0/0.30. This is my wireless VLAN, so I'm going to bring up my. Oh, I have a mistake in the other one. I'll go fix that. This is my wireless VLAN. I think I'm going to caught my error. I'm going to go fix it right now. I'm going to go back over to 20. I'm going to change my description from staff to wireless. There we go. Interface Go back over to my wireless interface. We already have our description input in. Oh, I made a mistake again. Lose my mind, folks. Losing my mind. That would not have been. That was not my wireless. That was my voice VLAN. I need to encapsulate interface G0/0.30, and we're going to encapsulate this .1Q to 30, do an IP add 172.16.192.1 and 255.192.0. Let's end. Now I want to see if I got everything programmed right, because I made a lot of mistakes when I was doing some of my coding there. So let's take a look, make sure it's all good. We're going to do a show IP interface brief, and you'll see that G00 does not have an IP address to it. .1 has 122.16.0.1, and it is up and up. Gigabit 0.10 is 664.1, up and up. .20, it's 172.16.128.1, and the .30 interface is 192.1. Also, if I do a show run in this case here, I can also look at my interfaces, because that's where I was screwing up all my. Oh, yeah, look, I got a mistake right there. Staff for that one, VLAN 20 should say voice. So I'm going to hop into that interface real fast here and fix that. So interface G0/0.20, and my description for that is going to be router interface for voice VLAN 20. Get out of that. Do my show run again. And we'll see that I have my admin, my staff, my voice, and my wireless VLANs all set. Okay. If on this router here, I wanted to have my G01, which on my physical network I plug into the internet port. I would then say interface G0/0/1, and I would say IP address DHCP. And what will happen is it'll talk to the DHCP server on the other side of the network and pick up an IP address there. And do a node shutdown, so that interface would come up after we plug something into it. Right now, there's nothing plugged into it. You can see that I'm green the whole way around here. So let's hop over here to PC1. Based on the map that we had set up, we had made this guy on PC1 172.16.64.10. The subnet mask on this should be 192.0. The default gateway should be 172.16.64.1. And close out of that, and close out of that. Let's hop on to PC2. Let's do the same thing over here as well. 172.16.128.10 with a subnet mask of 192.0. Default gateway of 172.16.128.1. PC3 should have an IP address of 172.16.192.10 with a subnet mask of 255.255.192.0 and a default gateway of 172.16.192.1. Now that those are all plugged into each other, we can go ahead and see, can we ping? We're in PC3 right now. PC3 should be able to ping its own gateway if we have everything up and running correctly. So 172.16.192.1. And you can see the information is going up through our trunk line and hitting the sub interface of 172.16.192.1. Let's go ahead and do the same thing. This guy should be able to ping his default gateway, which is 172.16.128.1. And he also can ping his gateway. Let's go ahead and take a look, make sure PC1 can do the same thing. And then we'll go through and see if PC1 can ping PC3, 172.16.64.1. So we know we have at least partial communication working. Let's go ahead and see if we can ping PC2. See if we can ping PC2's gateway. It can. Now let's see if we can ping PC2 itself. And we can. So now what we've done is we have gone ahead and been able, we've created the routing on a stick interface. We have 3 networks running inside of this one router. And we can now communicate to all of our other PCs on the network. So that is routing on a stick. Now, if I wanted to take it one step further, I could actually go to my end devices, grab myself a server, and put it right here. This server, what I can do is make it simulate that of, say, the cloud interface. So let's go to Services, let's go to DHCP. We're going to go ahead and turn the service on. We're going to say this is going to be 192.168.100.250. My DNS server on this network is 192.168.100.8. I'm going to start my DHCP pool at 168.100.10. I have a default subnet mask on this network. And that should get DHCP working on this network. But first thing we have to do is assign an IP address to this network so that we're on the same network as the one we're going to pull the DHCP from. So let's go ahead and give ourselves 192.168.100.2. Default subnet mask. We'll give it a 192.168.100.250. Give it a DNS of 192.168.100.8. So now if DHCP is running, we should start to see right now it has not picked up an IP address yet. Let's jump back at our server and make sure it's set up. Can't do anything if we don't plug it in, right? Let's go ahead and plug this into G01 and this guy here into Fast Ethernet 0. Let's fast forward time a little bit, come back on here, and you'll see that we just received an IP address of 192.168.100.8 on our network. So now if I do a show IP interface brief, that we now have our inside and our outside addresses 100% working. Now, the ability for the other addresses to be able to communicate is going to be a different lab where because we have to translate these addresses into this address over here, and that's something called IP NAT or IP Network Address Translation. So these guys would all be then considered IP NAT inside addresses. This would be my IP NAT outside interface here. Then I would just write an access control list to allow this information to be translated. Right? But that's going to be for another lab. I hope you enjoyed tonight's lab and you got some good information out of it. Go ahead and submit your information to me in your in the Dropbox, and I will see you soon.